And then they're going to start asking questions. So at what height? So they're looking for H. H equals, we don't know, was the object fired. So if they're asking you for the height when the object was fired, and they're not telling you what T equals, you tell me what T equals. What is the time at the moment the object was fired? 0. They didn't give it to you on a silver platter, but we are human beings and we are smart enough to realize that, 0 seconds have passed at the moment the object is fired. So we're just plugging in 0 as our T. So H of 0 equals negative 16 times 0 squared plus 112 times 0. What is the height? 0. 0 feet. Okay, so it was fired from the ground. Not all things are fired from the ground. You're going to see problems where it's fired from the top of a building or something like that. But firing objects just because of gravity is always a good quadratic model, because let's say you fire something from a certain height, when you fire it up into the air and then it eventually comes back down, so as time passes, your height kind of carries on that form of a parabola. So it's common for the word problem to be about like firing an object into midair. Okay? Sketching a curve of this particular one, this one starts on the ground with a height of 0. It's getting fired up, and then it's going to come back down. Okay, so this is your time, and this is your height. So just kind of to have an image of what's going on. And then part C says to find the time, so we're looking for T again, that the rocket reaches its greatest height and the maximum height. Okay, so to find the greatest height, where is that going to be relative to your roots? In the middle, exactly. So we obviously know that it starts on the ground at 0 seconds. If we find this point, we can go halfway in between. And what we learned yesterday from quadratics is that the roots are the solutions to the quadratic. So if I want to know this other moment where the height is 0, does everybody agree that the height is 0 here? I'm going to plug in a 0 for the height. And then I'm going to solve this quadratic. And why am I not going to waste my time with the quadratic formula? What's the more efficient way of solving this? Solve by factoring. There's a GCF here of negative 16t. I pull that out. What's 112 divide out negative 16? Negative 7. So when I tee it up, I get time equals 0. I knew that. The height was 0 when the time was 0. And also time equals 7. So I'm going to go up and label that 7. So it's going to reach its maximum halfway in between there at how many seconds? 3.5 seconds. So max height at 3.5 seconds is, how are we going to find that out? We know the x-coordinate is 3.5. How do you find the corresponding y-coordinate that will give us the height? Right. 3.5 is the number of seconds. If you want to know what the height is at that moment, plug it in. So we're going to do h of 3.5. And then we'll just type that in onto our calculator. Negative 16 times 3.5 squared plus 112 times 3.5. All in one shot. I can type that all in one shot. Negative 16 times 3.5 squared plus 112 times 3.5, 196 feet. And we actually already did D. Yes? So if you find your two roots, your maximum or minimum, your vertex will always be right down the middle. Okay? Any questions on that? All right. Exercise 2, different equation, but let's read into what y and x stand for. A skateboard half-pipe ramp has a shape in the form of a parabola whose equation is this, where x represents the horizontal distance across the 20-foot wide half-pipe, and y represents the ramp's height above the ground. So you're going to have something that looks like this. Okay? And this is the horizontal distance. Someone's like skateboarding up and down this. See him? See him going back and forth? Horizontal distance across. Now the overall width of this is what they say. 20. And then this is our vertical height. Okay? Now, they say to sketch a graph with the help of your calculator. So you don't do this just so we can go through it, but just watch. 0.06x squared minus 1.2x plus 7. My window, because it's a half pipe, I'm going from 0, and we know it's only 20 units wide. The height off the ground is my y coordinate. I'm going to go from 0 to, how tall do these things get? 20 feet? I don't know. Perfect. There it is. There's the model for it. Label its height and its endpoint at its endpoints. So we would want its height there and there. So its height there is at a horizontal distance of 0. So I could just do second trace value and plug in 0, and I'm going to get its height of 7. And then its height over here, right here, is at an x-coordinate of, what's the x-coordinate way over here? 20. Second trace value, x equals 20, is also going to produce a height of 7. We should have known that. That's going to be symmetrical. And its minimum point. This is second trace. What do I do to find its minimum? Minimum. Left bound, scroll over. I got to go way over. Left bound, enter. Go to the right of my vertex. Enter, enter. And my minimum point is at 10, 1. Okay? So the minimum height off the ground is 1 feet, right? That makes sense because the half pipe has to have some thickness to it. And then that vertex is halfway in between the endpoints. That should make sense. Okay? So really your homework is just to read and plug in numbers for the variables that they stand for and find the missing one. A little bit of use of your calculator, which is review. We've kind of done minimums already this year. You got your spiral on the way in. Now you're doing your homework. Am I missing anything?